Okay, this is coming from an exam question, and I don't think it will come up for our exam, but I think it is pretty nice if you learn this also, since I have this understanding. Alright, if you don't know anything about the passive filter or op-amps, I would suggest you watch this video. Alright, it's under my playlist RC and RL passive filter. Okay, and you can watch all this. And although it's not very good, but at least you get a few understanding of how the low pass and high pass are being connected within an op-amp a little bit lah. Okay, so this thing over here is your R1, because it's R1 over here connected in series with this thing. So this thing over here, or we want to multiply by certain current, it will give you a voltage. Okay, so in other words, this thing over here, alright, is your R. So if you remember, your V is equals to IR, right? So your current is your input current that is coming in, alright, from somewhere, alright. But in this case, the V in, but I mean there will be a current that is coming in. So your current coming in, alright, multiplied by your resistance. Alright, your resistance is gonna be talking about this capacitor FC. FC, if you remember, is 1 over 2 pi FC. Okay, and things like that. So you're going to solve for all this thing, and eventually you can come out a equation to represent your stuff. So this thing over here, if you think about it, it looks a bit similar to your K A over if I were to bring this FC to the other side, so something like a S plus A. You see, your R2 is somewhat your resistance, alright, and your FC, because it's controlled by your 1 over 2 pi FC, your frequency of your frequency. So frequency is talking about J omega, you see. So at least you can see the link now. Multiply, so this is your transfer function, you see. Multiply by your current. Your current is your input. So far, we can call this US, alright. And in our convention, normally we say it's ES, correct? Is equals to your US, your output voltage. So this thing over here is your voltage divider or your current divider, if you remember. Alright, you just go and search lah. Alright. So how you connect in terms of the current and things like that, this is how we do so lah. I may be wrong in this transfer function, but at least you get to see that this thing over here comes out in a pretty nice graphical way. Alright, your R1 is your K lah, in other words. So yeah lor. Therefore you just calculate your R, your resistance all over, and then you can set up your transfer function already. And that's all. I think it's trying to say that extract the transfer function. So you just calculate, you have your R1 and R2, you can just calculate your C, alright, based on whatever frequency. I forget how to calculate this lah, but at least you get to know how things works already lah. Okay, and then in the next part, this thing over here give you this thing, alright. Then they ask to tell you find the resistors and the capacitor values. So you're working backwards. Currently what we're doing is to find the transfer function. In this case, they give you a transfer function and you are asked to find the resistors and capacitor values over here, alright, at all the sites. Alright, so these are the things that you may want to know lah. Alright, but at least this is something extra I find that is pretty useful to evaluate this type of problem if needed. Alright, so although it's not a full-fledged answer, but at least it'll give you a pretty much fairly well understandings. Alright, so see you soon.